Hey guys, welcome to this session on AWS Lambda. AWS Lambda is considered to be one of the most used and popular services, but what makes it popular and effective at the same time? Let us see that in this session. So before moving on with this session, let us take a quick glance at the agenda. So first we'll be learning what is the distributed application architecture. After that we'll move on with what is AWS Lambda and why it is used. After seeing that, we'll move on to the core concepts of AWS Lambda and its use cases. After looking at that, we'll see what are the benefits and limitations of AWS Lambda. And finally, after learning all the concepts, we'll be doing an hands-on on AWS Lambda to understand it better and practically. So let us move on with the session.
As I already told you, in this session, we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our local host and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc1 and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had two images and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc1, and this one was uploaded from this localhost. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session and then we'll move on to the hands-on part. So come on, let us go.
Okay guys, now let us begin with the session. So typically an application comprises of three components: the front end, the back end and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end and the database service, on an individual server. So what happens here is, whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help and it will store somewhere and it will show the response in your website. Also, there needs to be information stored in the database because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is front-end service uses 80%, but the backend service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now the system falls under a deadlock, and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture? It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all the software components was hosted, so what happened there was backend server will consume most of the CPU resources, and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website, and this website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources, and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front-end server, and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service. And whenever to retrieve this particular image, the database service provides the link, and the backend service will use that link to show the image to us. So let us consider this, and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front end, the backend, and the database services club together. So now we have learned what is a distributed application architecture and how the front end, the backend, and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda, and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now, what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service, while EC2 is an infrastructure as a service. In Lambda, it provides you a platform to run and execute your backend code
but in EC2 it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C#, and a few more. No restrictions in EC2. You can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2, you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later, we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors, so you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is the maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds.
So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs. And after that, the Lambda executes the function or the code in your behalf. You don't need to run it. So, but to run the code, you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. You need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger, and whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description. Description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds because that is the capacity or that is a timeout period for a function which I have already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment you can run a Python file, a Java file and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes and these were already announced. So first it's .NET Core 2.0, C#, so and then Go programming language, and then Java, Node.js, Python 3.7 and Ruby 2.5. And the other supported languages are Node.js but an old version 8.10 and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes and other dependencies. Instead of downloading using the code which you write in your Lambda function,
You can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers, and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file, so what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in development function code independently from unchanged, like you don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally, Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket which it is connected to. Also, whenever a put operation occurs, that is when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do a hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is, we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is, we are going to upload 3 types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket. And whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is, we are going to use the S3 buckets uploading, that is put as or post as a trigger. And whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So let me show you the code first. So this is the code. There are two files. One is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is normally if it does not exist, $key will be just $key. But if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we've seen this code. Now let me show you the Python code which is used for the Lambda function. So in the Lambda function, using that, we are going to send this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly, and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket. I'm getting the name here. This is the file name. I'm getting it here. And copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from, and this is the object which is going to be uploaded, and this is CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like you can go to that log streams and check out these things when the function has started. So when the function started, this will be there, and after that this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't, you check whether extension. First you get the extension or the last 4 characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object bucket, this is the destination bucket, this is the file name, and this is the copy source, that is the file which you're going to upload from the bucket. That is, from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code. Let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that, and you have to attach a policy. And I've created a policy already which is s3_move. So you have to create a policy and use this particular JSON code inside it. So I'll explain what this means. So I'm giving effect allow, and also over here. So here I'm giving the actions logs, create log group, log stream and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First, you have to create a role which lets Lambda call other AWS services. So here, after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next you have to give it permissions. You can see here there are a lot of permissions, that is, there are policies available. So before we created a policy s3_move and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3 and I'm searching CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tags. I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are 2 policies attached, Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role and now the role has been created. And as I showed you before, here you can see this, and also I can go into the policy and show you the JSON part. This allows all the actions for S3 and the other policy allows all CloudWatch actions. See, you can see in the JSON. So you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part. So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let us create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything, you don't need to give any tags, so you just click next and it already sets permissions, so block all public access, and also if you want you can review it once and then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image and I've created that. Okay. Next thing is I'm creating to the bucket PDF and I'm giving next and create bucket. And finally I'm creating to bucket text. So I'm giving next and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless apparatus or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python. So I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created a role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is see, I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7. This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever a object is uploaded to the S3 bucket from the bucket, then this process will start happening. First let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our lambda will be triggered right now, and that function will be running, and this process would have happened. So I refreshed it, and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3, and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now, and it gets segregated according to the extension, and it gets copied. So I told you after execution of the function, you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics, and here you can see some data. So this is invocations 1. So the function has run one time, and the duration is given here. And also the success rate was 100%. There was no errors. So you can see that here. Also let me show you the logs. So a log has been created. I'm opening that. So you can create. So function start CloudWatch. So let me open the code first. Okay. So here function start CloudWatch. And you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name, and request ID has been So after the request ended, it is ending the report and the report has been sent. And you can see here it took 566.10 milliseconds and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk, and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda demo. And I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is the default PHP page, and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code because okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in filelogic.php you have to change the path because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/ your file. So index.php and filelogics.php will be in this directory, and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is you have to click on all the files and choose over here, and you have to archive it into a zip file. So if you ask why should we zip it rather than make the file a rar file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button. So I have to choose a file. So what I have to do is I have to go back. We go to AWS demo. So this is the file which I have to upload. So AWS uploads file logic and index files are within this particular zip file. You should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda demo. So it is AWS Lambda demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket it's empty, and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, doc.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket and you can see the PDF file over here. And then finally to the text bucket, and I'm refreshing it and you can see the text1.txt file over here. So right now our Lambda function is working and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded from the bucket and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image and then PDF and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy and first we created a role and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3, which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens and this function code runs. So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk and we deployed it, and we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that, and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution, and this is one particular function execution. This is one. This is one. So the function has been executed this many times and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100% and there are no errors because all the files which we were uploading got uploaded and the function never got any errors and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM so that we have to create a policy first, and then we know how to create S3 bucket. We know how to write code in a Lambda editor, and then we know how to use CloudWatch, log streams and also metrics, and also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL. You can access it from anywhere in the world.
So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites, the second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it.
You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services. You can use services like EC2, S3, and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
Okay guys, we've come to the end of this session. I hope this session on cloud computing and AWS was informative to you. If you have any doubts, feel free to comment about it below. Thank you.